Good day, I'm Dr. T and welcome to my office. So today I'd like to talk about elimination reactions. These are effectively the opposite of addition reaction. It actually can occur in one of two different ways that are fairly similar but have a couple of distinct characteristics to them. Overall, for kind of looking at a survey level, the distinctions between the two ways isn't that big of a deal. Obviously, if you're going to be doing a deep dive on organic chemistry, then the distinction becomes much more important. But I'm going to keep it fairly surface overview in this video. Okay, so an elimination reaction is the opposite of an addition reaction. I'm going to take a couple of carbons, and I'm just about always going to have a hydrogen here. And I'm going to have a leaving group. Okay? Now, this guy is going to, once again, one of two versions. The direct opposite is what we call an E1. So in an E1 reaction, the first thing that happens is the leaving group, let's see if you can guess what it's going to do, it leaves. So the leaving group will leave. And then you have some form of base. The hydrogen donates its electrons to where the double bond will become, and the base is going to pick up the hydrogen. Quite often, this base is the leaving group. And from there, you get yourself an alkene. Yay! Now, the other approach is an E2, and in that case, we're going to do this in one step. So in this step, we have a base. The base attacks the hydrogen. The hydrogen's electrons go to the middle, and the leaving group's electrons leave. And we get our alkene in one step. Now, of course, you're sitting there going, wait, E1 is two steps, and E2 is one step. The 1 and the 2 actually represent how many different players are involved in controlling the rate of the reaction. Because this step is usually limited by this part of the reaction, how long it takes for the leaving group to decide to just leave, this is controlled basically by the concentration of this. Whereas in this step, you have both how much of this you have, but also how much of whatever is going to pull off that hydrogen, or whatever group is going to be coming off here. This means you have two components that control the speed of this. Therefore, the 2 is representing how many different things are required to affect the speed of this reaction. Okay, so let's look at a specific case study of this one. And this is going to be the exact opposite of one we already did. So in this case, we're going to go this guy. We're going to have ourselves a nice little alcohol. And in this one, typically this is done with an acid catalyst. This is going to change how the OH behaves. So in this case, we're going to have an acid catalyst, and hey, that oxygen is going to pick itself up an H, so it's going to become this guy. Then, well, that's going to leave, so now we get and then OH, H, and then this guy's got some lone pairs, and it will attack the hydrogen. So at this point, we then get out of space, so I have to drop down, our double bond, and we get ourselves some H3O+, which of course is, your classic acid. Now you're sitting there going, wait, isn't this the exact opposite of the one we did earlier? Let's see if I can find that slide. Slide, what am I talking about? Let's see if I can find that piece of paper. Yeah, isn't this like literally the exact same thing we did earlier? Why is this happening? Let's see if I can get this straight. Why is this happening here, but this going the other way here. And the difference is going to be the reaction conditions. So in this case, I'm going to have very, very little water. I'm going to have a lot of acid, probably some nice sulfuric acid, but very, very, very little water here. So that this reaction isn't going to want to take place. There's not much water. There's very, very little of this. I may even put reagents in there to suck up the water to get rid of it. And this is going to allow me to dehydrate it. But if I had lots of water present, and this is usually done with an acid catalyst also, or this can be done, I should say. I won't go usual, but it can be done with an acid catalyst. Then in this case, because I have lots of water, it's going to go towards this one. I'm going to get an equilibrium. And, of course, just because life is fun, this has a carbocation intermediate. In both cases, that means I can get rearrangement or weird side products as well. So, yeah, interesting things can happen with this reaction. Thank you and have a wonderful day. I will see you in later videos.